Hi everybody, thank you for joining us today. We are here again at the Experience Center at Makino's Die Mold building in Auburn Hills. I'm Mark Bay. I'm one of the market segment managers, Makino. My responsibility is EDM and consumables. I'm here with Chris Frost again. Chris, thank you for joining us again.
Thank you for having me today, Mark.
And Chris is Director
of Sales and Marketing for Bedra USA.
Yeah. And today is the last of our multi-part series on the history of wire manufacturing, EDM wire, and today's focus is on the production process of EDM wire as it is done today.
At our facility in Germany. The quality of the production, yes. So let's get started here, Mark. What we have here is a process route for Bedra EDM wire. 100% of these processes are done in-house. We can look at these processes here today, but we'll go in deeper into each one of these. There's 15 steps from the beginning with the virgin material until that final product is packaged. And each one of these steps have different quality controls and checks and balances in them. Starting with our material, we only use virgin raw materials at our facility, in our casting facility in Germany. Mark, I want to go to the next slide here, and then we'll start each one of these processes and kind of work through them on slides, if you don't mind.
Absolutely.
All of our R&D is done in-house. We have very high standards that have been developed over the last 30 to 40 years of manufacturing EDM wire. Our standards, we duly develop wire design, we validate the performance, and we optimize the production technology.
What does that do for me as an end user? You know, if I run my EDM on a day-to-day basis, what does this mean for me?
Consistent results from spool to spool, batch to batch of the wire that you purchase. So that what you buy today is going to be made the same way it was made a year ago.
Okay.
So you are going to see has been some changes in the last 20 years, some advancements in many different areas. But each one of them will still guarantee that you have highly reproducible results on the wires, which should save you cost based on higher throughput of your machines. The more efficient they are.
So the foundry, that's essentially like where the alloy is made, is that correct?
Yeah, that's where we cast virgin materials to produce rods that your wire is manufactured from. But we only use high-grade virgin materials. Homogeneous internal microstructure and the tightest alloy tolerances that are tested before that material is put into that casting to produce the base material, or the base rods that final spool of EDM wire is going to be produced from.
And that again leads to the consistency from batch to batch, spool to spool. So once I have my settings correct for this product, if I dial it, if I'm a good operator, I dial it in specifically, then I know I can run like this day in, day out.
Day in, day out, consistently. You're going to be at a very low risk for wire breaks. Your results are going to be, from part to part, very consistent. So if you run a part at 1 o'clock in the morning or at 1 o'clock in the afternoon, you're going to get pretty close to the same times, but the same finishes also on that part. Electroplating.
Does it happen for every wire or only for specific wires?
Not for every wire. And each wire family has a different coating on it. If you look at just a plain brass wire that most customers and most EDM people are familiar with, there's no coating on it. It's just the brass wire. It's cast from the casting furnace drawn down to the final size, spooled and packaged and sent to the users. But some of the wires, the modern wires, the gamma wires, the diffusion annealed wires, the beta phase wires that many of our customers use have to be plated. And what that means is that we're putting a coating on there. It's a mixture of a few different materials that we coat to a certain micron level, which is very controlled, and then we anneal it in one of the other processes we go through there. And we convert that coating into either a beta phase or a gamma phase, or a combination of two with some of the Gen 3, Gen 4 wires. We control the thickness of all layers within microns, and we have a strict fulfillment of what we do with the materials that are left over after that electroplating process.
So Chris, with electroplating, is that always done in the same way? So let's say if you compare electroplating for traditional copper cut A wire compared to electroplating for, a super modern, more recently developed heat extreme wire, or are there differences?
Mark, the process of electroplating is the same. The amount of electroplate and the composition of the material that is electroplated onto the wires change. So where your Cobra Cut is a very simple electroplate of a single layer, your heat wire is a multi-layered composition that is electroplated on it prior to being diffused.
So multiple layers, different materials versus,
Different materials, different annealing temperatures and conditions.
Or
I should say diffusion.
Yeah.
Diffusing instead of annealing.
So let me take that a step further. So, the combination then of different types of alloys as the core with the different thicknesses or types of the cores is then what gives me basically the final characteristics of the wire, yes, which can be, let's say, adding speed or
precision.
Precision
Okay. Can be built into the wire.
Yes. Okay.
Yes. And we can add speed by changing the composition of that coating material and also the thicknesses of that coating material on the wire. Drawing and spooling. This is a very detailed step. Mm-hmm. That this process takes longer than most people would think to wind a spool of wire. A spool of wire doesn't get wound in just 5 or 10 minutes. It takes a wire to do that, especially when some spools you're winding 15 to 20 miles of wire on these spools.
Or sometimes even, I've seen, if you go to a smaller diameter on a larger spool, it can easily be 40 miles.
Oh, absolutely, absolutely. And you have to be able to guarantee that that wire is going to always come off of them spools. And we do a lot in our process to do that. We control the deformation individually adapted to the wire types. We control the microstructure on the surface of the wire. We have to keep that wire straight. We have to have very uniform on the spooling. But after all that's said and done, it's got to be clean too. This is not something that is easily done, but it is something that we can do consistently from spool to spool, batch to batch, year to year.
And if that doesn't happen, or let's say if there's, a break in the process or a blip in the process, right? Sometimes equipment can break down or what have you, then I guess what can happen is reduction of, auto wire threading may not happen as well.
You may get wire breaks, Mark. You may have lines in your parts. You may have debris building up on your machine in your auto threader. And this is why Bedra takes steps to ensure that the quality control is checked at each one of these points. This wire is individually sampled to make certain that the quality is there from the start all the way through to the packaging. We have various quality control steps that we take with each batch. In fact, Mark, we're able to track this back to the day, to the month, to the operator that ran that wire for any spool that is sold.
Drawing dies. So
Drawing dies are interesting. We now use approximately, give or take, 30 dies made out of either natural diamonds or polycrystalline diamonds.
for one to get
One diameter. For one diameter. To take that wire from 8 to 9 millimeters down to the finished size. One of the advantages that bedra has is we have a custom die shop attached to one of our facilities where we build our own dies and we service our own dies. So we control the quality of the dies. They have to meet our stringent requirements before they leave that shop and go into our production lines. This makes certain that our wire surfaces are consistent. Our wire diameters are concentric, and that the straightness of the wire is maintained from batch to batch.
Okay. Again, leading to consistency for me as an end user.
Flawless part surface.
Precision.
Yeah, reliable AWT. Your threading is very reliable like this. And it reduces the amount of wire breaks that you have. It helps with the maintenance of your machines because you're guaranteed a high quality wire when it comes through there with quality dies. And these dies are checked and they're replaced at set intervals.
Mm-hmm. Okay. So you mentioned the maintenance of the machine. So let's say if the quality is subpar, what kind of maintenance are we talking about? Or what kind of wear and tear are we talking about that we could, introduce to the machine by...
Some wires are rough and they can have an effect on some of the rollers on the machines.
Wear them down, essentially? Is that what they do?
Yes, wear them down, exactly. Other wires, if they're dirty, if they're not annealed right, or they're not cleaned right, can leave a powdery residue not only on your guides, your upper part of your guides, but also within your power feed contact housings.
Mm-hmm.
And this can become a problem because you're running with deionized water. And a lot of your coatings have zinc in them. So if you shut your machine down and you have zinc particles there and the water evaporates, it can create problems for your employees or for the shop employees that they have to clean that machine to make that machine work.
Mm-hmm.
So the quality of the dies is very important.
Yep, that makes sense.
Diffusion annealing.
That's been around for a long time, I believe. Is that correct?
That goes back many, many years ago to a Bronco Cut X wire.
Sounds like a familiar name.
Oh yes, if you've been in EDM longer than a couple of years, you've heard of the famous Bronco Cut X or copper cord wire. The diffusion techniques for diffusing or annealing that coating is different than what it is for a brass type wire. Different times, different temperatures, because you're now working with different thicknesses. So the diffusion annealing doesn't need to be confused with the wire annealing, the core material annealing. The diffusion annealing is only speaking about the coatings of the wire. And this is to allow the coatings that you electroplated on to change the metallurgical structure into a gamma phase, a beta phase. What this does is if you have the right diffusion technology and the material converts correctly, it's going to secure the cutting performance and cause the wire to run faster and to have less damage to the workpiece, thermal damage to your workpiece.
Stress relief and soft annealing, that's something that I don't think you hear that much and we're not really that familiar with.
This has more to do with the core material, the brass rods. That material is cast, poured, and set by temperature, just by room temperature, and it's moved from there into a annealing chamber. The annealing chamber where this wire is put in and stacked, the component goes back over it, the temperature is brought up, and a gas is pumped in there. And what this does is it heats the wire up, it allows the material to recrystallize, and then it cools down over a period of time softening the wire itself to be malleable, to be workable, and also realigning the structure internally of the wire. This allows the drawing processes to go smoother as you're working with a soft material with no stress and not a hard material. And the wires will go through this a couple of stages as they come down from the casting material to the final size, and prior to having, if they have a coating on them, to the diffusion annealing. This allows Birkenhoff to better control the straightness of the wire, the tensile strength, and the elongation. And this is how we make soft wire or hard wire. So we use this annealing process if we want to make a wire with a 500 tensile strength or a 900 tensile strength. Quality management. As you can see, very well ISO certified. Our quality is controlled throughout the whole process, from casting all the way through to the final packaging. There are samples, as we spoke about before, there are samples taken periodically at different stages of the production, sent to our quality control lab in-house and tested. If there is a problem, that lot is stopped until we find where that problem is. If we have to, we'll pull that whole lot off and go with the next lot. We have a zero defect policy.
What does that mean?
We shoot in quality control to have 0% of defects. Of course, this doesn't always happen. It is a manufacturing facility, and we do have some problems that will slip through. But usually when they slip through, we can isolate them to 2 or 3, maybe 4 spools within a lot that have the problem. Because our technicians are checking at every stage and they're making adjustments. So if a piece of equipment goes out of adjustment, our guys usually can catch it on the floor quickly, make the adjustments. So if that spool wasn't checked, it may make it through. But we have a policy that if we have a bad spool, send it back, we'll replace it.
All right. Well, that brings us to the end of the production process overview as it happens at bedra. And Chris, thank you very much again for joining us. Thank you, everybody in the audience. And we invite you to stay on and ask us some questions through the Q&A. You see that on the top right of your screen. And if you click on the bottom right, you can enter any kind of questions, and we'll do our best to answer them. If you don't have the answers, we certainly have the ability to go back to the factory and reach back out to you. Thank you again for joining us here and letting us provide you this overview.
Mark, I want to thank you for allowing me to join you in these presentations. And as Mark said, if there's any questions, please follow Mark's directions. And if we can't answer them questions, we will get you the answer within a couple of days.
Thank you.
Thank you.
Hi, Chris. So thank you again. And so we have some questions here that are coming through. First one is how should a standard 44-pound roll of wire be stored in a shop?
It should be stored the same way as any other spool of wire. Do not stand it on the flange. Leave it setting flat on the rollers so that the wire doesn't have the opportunity to sag.
So meaning if this is your wire spool, you don't want it like this, that the wire kind of slips down.
Yes. You want it setting like this on the flange, on the bottom part of the flange there, so that the wire doesn't have a chance to slide down or compress into itself to cause tangles. Also, if you can, keep it in a dry environment.
Tangling is the issue then that could be caused by this?
Yes. Yep.
And that means wire breaks, is that correct?
Wire breaks, and you'll see the wire where it'll be jerky coming off the spool.
Mm-hmm. Okay.
Or it'll get knotted up and it'll cause the wire to pull against itself because it's not free rolling, and it'll just snap.
Okay. And another question is every coated wire plated?
Is every coated wire plated? It does have a coat. Once you have a coating on the wire, you have added another layer to the core material. So to answer that question, yes. It just depends on the thickness of how you plate the wire and whether you electroplate it or you run it through a hot dip process where you're just dipping it through a molting material.
And as a follow-up question to that, what are typically the materials that are used for plating?
Copper and zinc are the main ones, but there's a lot of additives that go into some of the newer ones. People have played with bismuth and many things that have been patented, many different elements that have been patented for EDM wires.
Okay, thank you, Chris. The next question that I have is, where do draw stock materials come from?
With the major manufacturers, a few of them produce their own. There used to be other draw stock manufacturers out there that would produce draw material or or spooled material for the EDM process. So there's only a handful of mills left that produce their own raw material or develop their own raw materials into draw stock. That number has dropped drastically in the last 15 years. And the thing to look out for there is that some of them are, and not really to look out because the technology has gotten better, that some of them are even using some recycled EDM wire in their pre-draw material or their draw stock, and they're casting it. And this technology has improved immensely since it first started in the early, about 2007, 2010, in that time frame.
Is draw stock and pre-material the same thing?
Draw stock is usually, in my opinion, and other people may agree or disagree with this, but draw stock is the core, pre-material is just the core material, the brass wire. Draw stock is usually the coated material, something that may have a coating on it, okay, or the other layer.
So it's like a one step or a couple steps further down in the manufacturing process.
But they're interchangeable terms when you talk to people within the industry.
Okay. Can you summarize like the issues that may result out of, let's say, an incorrect quality process or subpar manufacturing process? What does it mean for me as the end user or for my operator?
If the wire's not annealed right, it's going to break. It's going to cause you problems. If it's a soft wire and the annealing temperature is off, you will notice that the elongation will not be there and you will have a lot of wire breaks. If it's too hard, sometimes it won't thread. It'll break. It'll be very brittle. You can literally take the wire and just do this and it'll snap. Other times you can just take the wire with your fingers and pull it apart. This all has to do with the processes of the annealing stages. So there's a lot of places within a spool of wire that something can go wrong. And all the manufacturers out there have taken steps and quality steps to ensure that each process is monitored so that they can catch it before it goes down to the next step within the production line.
Okay, thank you. That was the last question that I have here. And again, thank you for joining and also for
those who may be watching a recording of this video in the future, you have Chris's and my contact information on there. Don't hesitate to reach out to us. Happy to answer any questions that you may have. So thank you very much again, and have a good day, everybody.
Yeah. Thank you, Mark. Thank you, Makino and SST, for allowing bedra to be part of your EC presentations. This is a great way for the industry to get knowledge on many, many topics from many experts in the field.
Thank you.
Thank you.